In this final video on options, we're going to look at I want to call it a little bit more sophisticated model, but actually it's a more practical model that's used by lots of investment in professionals with the purchasing of actual stocks and puts and calls. But we also have they've developed ways to apply this Black-Scholes pricing model to some capital budgeting issues, the issuing of bonds, etc. So it is developing as a methodology, if you will, of how to make some decisions in the corporate world. So it's referred to as the Black-Scholes option pricing model. And essentially what it does is the binomial model, if you remember when we talked about it, it looked at two outcomes in the future. And the binomial model, actually, you can expand it to more than two options. You can expand it to trinomial. You can add as many potential prices going out in the future as you want. But the Black-Scholes model looks at options and the stock price revolving around as a normal distribution where the mean is the exercise price. So that the value of the option is going to be positive to one side of the strike price, and the value would be zero or negative to the left side of the option. So it looks at this normal distribution. So we're going to utilize the normal distribution in Excel, and you'll see how we do that a little bit later. But there are some assumptions. One of the assumptions in the text here is that we don't have dividends during the call option's life. Now, there is a version, a formula of this that actually utilizes or includes the possibility of dividends. We won't apply that here, but there are versions of this that permit dividends to be paid. We're going to assume there's no transactions costs. The risk-free rate of return is known and is constant. It's not going to change. Security buyers can buy fractions of securities. So you can buy a part of a stock. You can also buy part of a risk-free asset, if you will. There's no penalties for short selling. You get sellers get immediately full cash proceeds. So there's everything is liquid as far as the pricing is concerned. The call option can be exercised only on its expiration date, and the trading of securities is continuous, so that stock prices move randomly in continuous time. So what we end up with is a rather complicated, well, here's the formula. So if you think about the value of a call, remember we said it's the price minus the exercise price. So all we need to do in this formula is to apply the normal distribution of the variables. So what variables are there? We have the stock price is P. The exercise price is X. We have the risk-free return. We have time, that's in days. And we also have the variance, or the square of the standard deviation of the stock itself. And I'm not going to go through and read through the actual formula here, but we need to calculate two numbers, D1 and D2. And D2, as you see here, includes or incorporates the information that we have in D1. And it's a pretty complex formula, to say the least. And it's a lot easier just to apply it than to talk about the formula itself. So here we have a stock Price is 27, exercise price of the options 25. Risk-free rate 6, it's a half year of time. And the standard deviation is 0.49 for this particular stock. So D1, if we calculate D1, again, I'm not going to go through all the formula here. That would take forever. But D1 equals 0.4819. Please check my math. Make sure I did it. Actually, I didn't do this math. This is the textbook did it, so I'm assuming it's correct. So once you have D1, we can calculate D2 is 0.1355. Now we need to calculate or determine the normal distribution function for the normal curve with this particular stock. So how we do this is in Excel, it's a formula. So you do norm equals norm dist for normal distribution, and then you put one of these numbers in there. So then ND1 is 0.6851, ND2 0.5539. So now let's substitute that into the formula. And what you'll see here, 27 times ND1 minus 25. This is the time element here, risk-free rate and time. Here's ND2. So when you calculate this, we have the value of the call is $5.06. You also note that this worksheet, the Black-Scholes worksheet that comes with the workbook that I provided, is $2.32 with the exact same variables and the assumptions. So again, $5.06 is the value of this call. So let's think about how this works, right? What happens if the variables change over time, right? So again, remember we had these 5 variables. We had stock price increases, and this is how I look at these parameters. We have stock price, strike price, time, the risk-free rate, we have variance. Now what happens, again, we have the stock price, we have it decreasing, but increases in all the other variables. How does that affect the call? Well, for these particular variables, for all of them except strike price, the if the parameter increases, the call value increases. But if the strike price decreases, again, that also means that the call will increase. If you look at the put option, it's similar, but yet there are a couple of differences. So if the stock price increases, since the put is opposite the call, the put decreases. If the stock price goes up, the value of a put goes down. If the strike price decreases, again, the put moves the opposite direction of the call. If the expiration date increases, again, time is a bet. The more time you have, the better your bet might work. Value increases. If the risk rate increases, the risk-free rate increases, the put value decreases. And variance, of course, if that increases, the put also is going to increase. And to check this out or to understand and see how this works, what I would suggest is to go to the Black-Scholes model, input this information, and then change one variable at a time and see what happens to these prices. Make sure that this table is accurate. So the last thing we want to talk is just a theory, but it's something referred to as the put-call parity. And the put-call parity says that there is an equality that has to hold within these securities or arbitrage is possible. So if you take a put, take the value of a put and the value of a stock, that has to be equal to the call plus the present value of the exercise price. So put plus P equals the value of the call plus the exercise price, present value. So if you wanted to buy a put, for instance, but you really didn't want to buy a put, if you bought a call, sold the stock, and invested in the risk-free asset for the expiration or for the exercise price, you would get the value of a put. And these would have to be equal. If they were not equal, you would buy the cheap one and sell the expensive one. And you would have arbitrage profits that are possible. This is what sometimes is referred to as financial engineering. So if you didn't want to buy a stock, you didn't want to pay the stock price, how could you do that? All you would have to do is buy the call, you would purchase the exercise price and invest at the risk-free rate of return. And then if you subtract put from here and subtract put from here, right, this would equal the stock price. And it would, again, it would have to hold for there to be no arbitrage opportunity available. So that's the end of this video. Look forward to seeing you in our next topic.